Welcome to the 7th video of algebraic expansion. In this video, we are going to give you some challenging problems and work this out together. More than working out together, we will discuss how to think through these problems together. It's very important that you give these problems a try before you try to find the solution. Please pause this video now and try your first question. If you have reached this far and got stuck, which is you have substituted for x plus y is minus z and z plus y is minus x and z plus x minus y and got stuck here, then you're not alone. Even I got stuck here when I tried to do this problem. The next step would be obviously to have a common, to make your denominator a common denominator. So that would be x, y, z. And here it would be z cube plus x cube plus y cube. And on the left side you have this term t is equal to. Wait a moment. In one of the previous videos we saw something interesting. If x plus y plus z equal to 0, then this quantity z cube plus x cube plus y cube, it amounts to something, and I would like you to pause this video and think about this. You have already seen what this could be. I hope you could recollect what we had done in the cube problems video. If x plus y plus z is 0, then we saw that x cube plus y cube plus z cube was 3xyz. So using that idea, you can find the value of this by substituting it. That's equal to 3. So the answer to your question would be 3. How did we reach here? So when you get a problem like this, the most important thing is to get started. So you don't just see, don't just stare at the problem. You try to do something. And here we did try. You try to find the common denominator and try to find the LCM and try to get into this form. Once you get into this form, well, you need some luck and experience, and if you would have seen something related before, then it can really help you. So here we had seen before that x cube plus y cube plus z cube, if x plus y plus z is 0, could be 3xyz, and we recollected that and tried to use that property. So try to find out, try to solve the next problem. Pause the video and try to solve the next problem. Let's analyze this before. A plus 1 by a is m, a minus 1 by a is n, and you'll find the relation between m and n. Okay, wait a moment. So if I add m and n, it would be 2a. If I subtract it, then it would be 2 times 1 by a. I can't do either of them. So probably I should be able to do something by squaring them or cubing them and then adding or subtracting to eliminate this quantity a and 1 by a. So that's a hint. Pause the video here and try to solve this problem. So here you go. You square m and n, and once you square m and n, you've eliminated this minus and plus in your end result. So now you can subtract these two quantities. On the left would be m squared minus n squared, and on the right, when you subtract both of this and this would go off, and this would go off, and what you get would be 2 minus of minus 2, which is 4. Or in other words, let's do it in this way as well. Minus of a squared minus 1 by a squared minus 2. So these two terms would get cancelled because they are same. Sorry, this was plus. So these two terms would be getting cancelled because they are same. You would end up with 2 minus of minus 2. That's 4. So to eliminate a, so here is your answer. This is a relationship between m squared and n squared. That would have no a. Here's the next question. If sum of two numbers is 5 and their sum of cube is 35, find the sum of the squares. Whenever you get a problem like this, it's quite easy if you translate this from English to mathematics. So sum of two numbers is 5 and sum of the cube is, sum of the cubes, x cubed plus y cubed, is 35, and you're asked to find x squared plus y squared equal to what? You may be stuck here when you see this for the first time. Now, there are two things given here, and we have to somehow trust that from these two we will be able to reach here. So one of the ways to go about doing that would be, hey, you know, if I cube x and y, I would get x cubed y cubed, and I can substitute on both sides. So if I can cube this and I can reach here, somehow I can make use of this and maybe come here. So here's how you think. I would urge you to pause the video and try to cube and see what happens, and see if you can reach to x squared plus y squared. So as you cube x plus y and you expand it, this is what you would get. You can substitute for your x plus y and x cubed plus y cubed. There you would get 125 minus 35 is equal to 15xy, and you get xy is 90 divided by 15. That's 6. Once you get xy as 6 and you know that your x plus y is 5, it's quite easy to find x squared plus y squared, because you can square and then you can get this. So what would be x plus y the whole square? That would be x squared plus y squared plus 2xy. You can substitute your values for x plus y here. 5 squared is, you know that x squared plus y squared is, x squared plus y squared is what you have to find, plus 2 times xy would be 6. This implies your x squared plus y squared is 25 minus 12, or that's equal to 13. So it's more than to solve the problem. It's quite important to be able to think through or think about the problem and try to see, hey, how can I go from one step to another and eventually lead to the final solution. So you may not know the path initially, but you get started somewhere and you reach a midpoint. In this case, we reached a midpoint where we found xy is 6, and then you reevaluate, hey, you know, from this midpoint, can I reach to the final solution? So that's a strategy for doing or thinking through these kind of problems. So I hope you enjoy this video. More than to solve these problems, you could go through how to think, and that's the most important part of solving any problem. So see you then. Thank you very much. Bye.